Hello, AP students. This is Mrs. Politsky, and I have notes for Chapter 2, Research Methods, Part 1. And we're going to get into talking a little bit about how psychologists develop new knowledge. We're also going to talk a little bit about the scientific method. And some of this is probably going to sound a little repetitive from your introduction class, which is probably good. So let's start about talking about how psychologists develop new knowledge. And it all goes back to talking about scientific methodology and empirical investigation. You know, none of the pseudosciences, such as astrology or palmistry, which is basically the reading of palms, really have survived any kind of scientific method because the fact that a lot of this is due to speculation and maybe some human gullibility. So scientists and psychologists, they all pretty much use the scientific method to test their ideas empirically. So scientific method, this is the 5-step process for empirical investigation of a hypothesis under conditions designed to control biases and subjective judgment. And empirical investigations, this is an approach to research that relies on sensory experience and observation as research data. In other words, we're going to develop some kind of experiment and we're going to be able to witness it. It's not based on hope. It's not based on common sense or anything like that. The idea is you're going to have a researcher that is actually going to find some hard facts and not necessarily use opinion to kind of come up with their results. And by doing one of these empirical investigations, hopefully we can develop something known as a theory. And a theory is a testable explanation for a set of facts or observations. It's not guesses, it's not winging it. And if you think about some of the great scientists like Albert Einstein and his theories of relativity, or Darwin's theories on natural selection, or some of the theories on social learning, or germ theories of disease, all of this is based on empirical investigation and not guessing. In your textbook, there's a little story about Emily Rosa and her project that challenged the whole idea of therapeutic touch back in the 1990s. And if you get time, that might be something that you want to go back and take a look at because at that point in time, therapeutic touch was kind of the buzz within the field of autism and things of that nature. And the truth is, it was not necessarily very scientific at all. So let's talk about the 5 steps of the scientific method. And this is pretty much a review for all of you. One of the things that you have to do is develop a hypothesis. And a hypothesis, for the most part, is a statement predicting the outcome of a scientific study, a statement that's going to describe the relationship among variables in the study. A lot of times people call it like an educated guess. Okay. Normally, if you're looking at a well designed study or experiment, you're probably going to have an operational definition. And that is a specific description of how the concepts involving the conditions of the scientific study, how you're going to go about proving that hypothesis, how you're going to measure things. Really, it's a way for anybody who might want to replicate a study or to scrutinize a study to go back and look at kind of what went into it in the first place. The second step is to perform a control test. And in a control test, you're probably going to have an independent variable. That independent variable is the condition that the experimenter is going to change independently of all other controlled experimental conditions. In a nutshell, it's the thing that gets manipulated. Okay. The experimenter wants to change this and control it and kind of play around with it to kind of figure out what's going on. Within that, you got to design something to kind of make sure that that independent variable is solid. And so you might see something like a random presentation. And a random presentation basically is to determine that chance alone determined the order in which the stimulus was presented. It wasn't um, like every second attempt we're going to present something. We want to make sure that when it does appear, it's actually going to be the factor that's going to change things. Along with that, you got to gather some objective data, and by doing that, you have something to measure against, and that's where the dependent variable comes into play. This is the responses of participants where it depends directly on the conditions to which uh, they have been exposed. So, again, kind of to make things really simple and right to the point, it's going to be that item that we're going to measure against. It's going to be the consistent that if you have a control group or an experimental group, both groups are going to probably have a presentation of that dependent variable. So in some cases, it might be like a test that everybody has to perform. And what we're going to do is we're going to look at the differences of the group that is exposed to the independent variable versus maybe the group that is not, and see whether or not there's any difference in that measurement there that's involving the dependent variable. The fourth step is to analyze the results, and you can start accepting or rejecting the hypothesis. And what's going to happen here is researchers examine the results to see whether or not the hypothesis has survived. You can accept or reject the hypothesis. In some cases, if there is statistical information that's available, it's probably going to be that data that is going to be kind of the root of determining whether or not the hypothesis has been proven. And then finally, the fifth step is the publishing, criticism, replicating of the study. So you may need to replicate, that might be to repeat the study again to see if the results are the same or consistent. In some cases, a researcher might conduct an experiment several different times before they even go public with a formal presentation of the data. The second thing would be validity. Does the research measure what the researcher set out to measure? Is it accurate? And there are going to be some times that there are going to be confounding variables that are going to show up. And sometimes that information actually is more interesting. But it just depends on what happens with the study. You can have reliability. Can the research be replicated? Is it consistent? If I want to repeat a study, can some other person, other group of scientists, take whatever I have designed, take my hypothesis, take my observational definitions, take that and go and perform a replication of the study and get the same results? And if they can't, there might be some questions there. Sampling, the process of selecting those participants or subjects for the study. How do we go about that? Are we getting a very good sample of the entire population? Going on, the population itself, this is the group from which the sample is going to be selected. Have we defined that? Is there a set group of people that we're looking for? Random samples within that population, does everyone have an equal chance of being selected? And then finally, the stratified sample, the process that allows the researcher to ensure that the sample represents the entire population. Have we taken the appropriate steps to make sure that that sample has been stratified? All right, thank you very much.